Welcome to the first session of chemistry class for class 9. In this session, we're going to start with the first chapter in chemistry, and that is matter in our surroundings. And I've divided this session into two parts. We're going to do the first part where we are going to define and classify matters. Then we're going to learn the characteristics of matters. I'm going to see the different properties of matters in the solid, liquid and gaseous state. So this will be in the first part. So starting with the chapter, we're going to see first the introduction. All right. In a surrounding, we see a variety of objects with different shapes, sizes and textures. All objects, in fact, everything in this universe is made of material which scientists have named matter. The air we breathe, the food we eat, stones, clouds, stars, plants, even a small drop of water. Everything is matter. Matter can be seen, tasted, smelled, or felt. Matter can neither be created nor destroyed. It can only be changed from one form to another. And we're going to see all these things with examples. So in this session, we shall learn about matter based on its physical properties. But before we see that, let's first define what is matter. What is matter? Matter is anything that has mass, occupies space, and offer resistance to any stress applied on it. For example, book is a matter, gold is a matter, wood, clothes, air, plastic, etc. are all matters that we see around us. Now, when we see the definition of matter, it says here that matter is anything that has mass. Now, what do you understand by the term mass? Now, when we say mass, it means it's the quantity of matter that is contained in a particular body, any body, a book or a gold, any matter that we see around us. All right. So it's the unit for measuring mass is kg. For example, to make it more clear, the quantity of grains contained in 1 kg of rice is considered as the mass of rice. Right? The quantity of the grains that is there in say 1 kg or 25 kg or 50 kg. How many grains are there in that kg? Those grains, number of grains, is nothing but the mass of this, right? So in any object we have this quantity. Like in our body also we've got bones, flesh, blood, everything. All this quantity makes up the mass of our body. And when we come across the term offer resistance to any stress applied on it. Offer a resistance to any stress applied on it means that whenever we press any matter, all right, we try to press any matter, they'll always try to oppose that. Okay, they're going to resist to that stress that we apply on it. So any matter, whether it's a book or it's a cloth or it's plastic or anything, all these they will try to resist or try to uh, to offer a resistance means to try to go against that stress when we apply on it. The next thing that we have is classification of matter. Well, in the ancient times, Indian philosophers says that there are 5 kinds of matters. All right, these matters were called Panch Tattva, and these are air, water, earth, sky, and fire. So they consider that matters exist as air, water, earth, sky, and fire. These were matters for them in ancient times. But nowadays, matter is classified into 2 groups based on its physical properties and chemical properties. So physical properties, for example, we're going to see the matter that exists in solid states, liquid states, and gaseous state. And the chemical properties of matter, we're going to see it in the second chapter of chemistry. For example, as elements, compounds, and mixture. Now let us see the physical nature of matter, or the physical properties of matter. If we study the physical properties of matter, we will find that every matter is made up of certain particles which differ in shape, size, and nature from other type of matter. Every matter is made up of certain particles. These particles are so small that we can't see with our naked eye. They're so small beyond our imagination. We can't even imagine the size of these particles. They're so small. Now let us see at the characteristics of these particles. Right? So we've seen that every matter is made out of particles. Now what are these? What are the characteristics of these particles? Number one, particles of matter have space between them. Alright? Particles of matter have space between them, whether it's in the solid state or in liquid state or in the gaseous state. All these particles, in whatever state they are, they should always have space between them. Then we have particles of matter are continuously moving, and these particles should always be continuously moving because we have got energy. Alright, this energy is called kinetic energy. Alright, because of this kinetic energy, they will continuously move continuously without stopping. The particles of matter tend to intermix or diffuse on their own with each other. These particles, when you mix one particle of one substance with another substance, they will tend to mix with each other on their own. Alright? Particles of matter attract each other by strong intermolecular attractive force. And these particles, when they of any matter, they tend to be together, even though if there's a space, but they tend to attract each other, right, by this force. And this force is called an intermolecular attractive force. Now you can see in this third point where we've used the word intermix or diffuse. Now what does the term diffuse mean? Diffuse means, or diffusion means, the intermixing of particles of two or more different substances in their own. For example, alright, if we take from the picture, if we take one liquid, say this is an ink, when you mix it with, say, water, as you can see there, the particles of water is in blue color, and the particle of an ink is in a pink color. So if you take a pink or a red ink, mix it with a glass of water, just a drop or two of ink, mix it in a glass of water, you will see that after some time, all those pink and red, blue particles, they will intermix with each other without anyone's help. So this intermixing of these two particles, of two different substances are water and ink, they intermix with each other on their own without anybody's help. So this intermixing of this particle is called diffusion. So they diffuse with each other. Another example, another example is, if you can see here, the blue particles are the particles of air, and the green particles, let's take it as an example of particles of a perfume. When you open up a bottle of perfume and you spray it, so what happens in that particular environment, in that particular surrounding? After some time, when the perfume is sprayed, you will find that the whole room or the place gets the smell of that perfume. We get the smell of that perfume in an instant. That means in a few seconds. Now what happens here is, these particles of the perfume, when they are sprayed in the air, in the atmosphere, they quickly tend to mix with the particles of the air very fast. And in this way, we can sense or we can get the smell of a perfume in a split second. So this is diffusion of two gases. One is the particles of air, the gases, particles from the air, and the second, which is the green color, is the particles of the perfume. So they intermix here on their own, and this process is called diffusion. Now let's come to the different states of matter. We, like we have already mentioned, there are three states of matter. We'll see the first state. The first state is called the solid state. So solid, first of all, let us define what is solid. Solid is defined as that form of matter. It is a matter which possesses rigidity, which means hardness. It's very hard. Its incompressibility, you cannot compress it easily. Okay, compress, or you can press it to change its shape easily. And it has a definite shape and a definite volume. All right, every solid has a definite shape. It comes in different shapes and it's different sizes. And it has a definite volume because it occupies space. Every solid occupies space. For example, here we can take sugar, sand, gold, copper, wood, etc. are solids. Now there are some properties of these solid matters. So number one is, like we have already mentioned in the definition, solids always have a definite shape. They come in different shape and they have distinct boundaries, all right, different sizes, and they have a fixed volume. Fixed volume means they occupy a certain space. Number two, solids possess high density, all right, it's got high density. Then the particles of solids are closely packed. Okay, I'll show you it in a okay. So these are the picture of the particles in a solid state. These solids are closely packed in this way, all right, and they are continuously moving in their own place without, you know, moving here and there, just staying in their own place, but they're still continuously moving because of the kinetic energy that they have. So these are closely packed, all right. Then the particles of solid do not diffuse into one another due to immobility of particles. Since they are immobile, means they can't move freely here and there. They're closely packed. So therefore, it is hard for them to diffuse with one another. Diffuse means to intermix with another particles. Next, due to close packed structure, solids are hard and have low compressibility. You can't compress them easily because they are so closely packed. The particles of the solid are closely packed, hence they are hard and they are incompressible. Solids have any number of surfaces. Right, so these are the few properties of solids. Next we have is a liquid state, the second state of matter. So what is liquid? Liquid is defined as that matter which possesses a fixed volume but has no fixed shape. For example, water, milk, oil, petrol, etc. They are all liquids and they have a fixed volume. They occupy space, but they don't have a shape of their own. They always take the shape of the container in which they are kept. If they're kept in a round container, they will take the round shape. If they're kept in a square container, they will take a square shape. If they are kept in a you know a rectangular container, they're going to take that shape of the shape of a rectangle. So some properties of matters in a liquid state are: liquids do not have definite shape, but they take the shape of the container in which they are kept. I've already mentioned that. Number two, liquids have a definite volume. They occupy space, so they'll have a definite volume. Liquids have low compressibility. You can't compress a liquid so easily. You can to some extent, okay? So therefore it has a low compressibility. Liquids are less dense than solids. Okay, the density, the thickness of liquid when you compare it to a solid is less. So therefore we say liquids are less dense than solids. In liquid, the particles are packed slightly loose, hence they can flow and be called as fluids. So because they have the capability to flow, therefore liquids are known as fluids. And they flow because they are packed slightly loose. They are not so tight. They don't sit tightly with each other, these particles. So therefore they have the tendency to flow. Alright. Then the next one is liquid exhibits slow diffusion. We've already defined diffusion. So when you mix one liquid with another liquid, there's an intermixing of these the particles of the two liquids, and hence they exhibit slow diffusion. It takes time for them to mix on their own. They do mix eventually, but it takes a time. Then the next one is liquids have only one upper surface. When you pour water on in a bucket, so the upper part of the bucket is the upper surface of the liquid. So it has only one surface. So this is how the particles of any liquid or any matter in a liquid state look like. They are constantly moving and they are loosely packed. They're not that tightly packed when compared to solids. So they can move around here and there, and therefore they have the tendency to flow. Now we come to the third state, and that is called the gaseous state of matter. Gases can be defined as that form of matter which possesses high compressibility and hence has neither definite shape nor definite volume. So gases are matter which possesses high compressibility. You can compress gas very easily, but they do not have any shape. As we can see, for example, air. We can't see the shape of air, and we can't easily, you know, calculate the definite volume or the space that it occupies. All right. So, for example, gases are oxygen, nitrogen, hydrogen, air, carbon dioxide, etc. All these are examples of gases. Now, let us see some important properties of gases. Some important properties of gases are, number one, gases do not have definite shape. All right, like air, we can't see the shape of air. Gases do not have a definite volume. We can't see how much of space it has occupied. Okay, air, we can't even measure it. So it does not have a definite volume. Gases have high compressibility. We can press gases and change it, okay, from one state to another at a high pressure. So we're going to discuss that later. Then gases possesses very low density. The density when you compare among solids and liquid, gases have a very, very low density. Gases undergo diffusion freely. It can intermix very quickly with other particles of other substances. As for example, I've already given. Okay, I'll show you one. Okay, so this is one example of how particles, they move in a gaseous state, and because of this property, they can intermix very, very quickly, very, very easily with other gaseous particles of other substances. For example, air is one example of a gas. It can, intermix with perfume, or the perfume can intermix very easily with air because the particles are so loosely packed that very, very loosely packed that they can in few seconds they intermix with each other very easily, and hence we get the smell of the perfume in the whole room when the perfume is sprayed, because the particles of perfume intermix very easily with the particles of air. So the next one is gas have a tendency to flow as liquid. Yes, so they can flow. Air can flow from one position to another as liquid, and therefore they are also considered as fluids. So we have two fluids here: a matter which is in a liquid state or in a gaseous state, which can flow from one place to another. They are considered as fluids. So these are just an image of the state of matter and how these particles look in different states. So this is how the matters of, you know, solid particles look like. They're closely packed. In a liquid state, they are a little bit loose, but in a gaseous state, they are almost free. Not even loose, they are almost free. They can move anywhere randomly, anywhere, without anybody being able to control it. Now let us see what are the factors that governs the state of matter. Okay, what makes a matter, exist in a solid state or a liquid state or a gaseous state? Now, like I've already mentioned, the intermolecular attractive force is always there in between the particles, whether in a solid, a liquid, or a gaseous state. This force should always be there. All right. So what happens is this intermolecular attractive force. It is present in all the particles, and in between the particles of solids. This force is always there. They keep the solid in closely packed because of this force. Right? They attract each other, and hence the substance exists in a solid state. Even in a liquid state, also it exists, but it is little less. So therefore, they are loosely packed. The force, this attractive force, intermolecular attractive force in between the particles of the liquid is a little bit less. So therefore, these particles they um, tend to move a little bit loosely. I mean, far from a little bit from each other. Whereas in the gas, this intermolecular attractive force is so less or negligible. It's very less or negligible. Negligible means it's like it's almost not there at all. So this makes the particles of a gas, move randomly here and there because of the less intermolecular attractive force in between them. So the intermolecular attractive force are responsible for bringing the particles closer while the motion of the particles tend to move away from each other. When the intermolecular attractive forces are very strong and the kinetic energy is very small, remember kinetic energy is nothing but the energy that helps the particles in any state to move in their own place, or it can move randomly here and there as in the gas. So because of this kinetic energy, they can move. They don't just sit in one place. Alright, so when the intermolecular attractive forces are very strong and the kinetic energy is very small, the matter exists as a solid. So this is one factor which governs any matter in a solid state. The intermolecular force, attractive forces should be very strong and the kinetic energy should be very small. Then only the matter exists as in a solid state. Next, when the intermolecular attractive force are strong, means the force of attraction between the particles is strong and the kinetic energy is large enough for the particles to move to and fro, the matter exists as a liquid state. So when these particles in a liquid state, when they have more kinetic energy, they tend to move here and there a little bit further from each other, a little far from each other, not so much. So because they have this kinetic energy, hence they are loosely packed and they tend to move here and there a little farther from each other. They move to and fro, and hence they exist in a liquid state. But when the intermolecular attractive force are negligible means it's so weak, all right, very weak, and the kinetic energy is very large, the matter exists as a gas. So when this particles in a gaseous state, they have a maximum amount of kinetic energy. Because of this maximum amount of energy, they don't like to stay in one place. They move randomly here and there, very far from each other. So this makes them exist in a gaseous state. So to define kinetic energy, it is nothing but the energy possessed by a body by virtue of its motion. Because it can move, it possesses, because of its motion, it has the capability to move here and there. Because of that, it possesses this energy which is called the kinetic energy. So with this, we've come to the end of the first session. Uh, we're going to continue with the remaining topics from this first chapter in the next session, that is part 2.